A wide variety of modern systems depend for their operation on an invention devised at Bell Laboratories more than 50 years ago. It continues to be used throughout the Bell system in telephone sets, the newest switching machines, and modern systems for transmitting telephone calls. This is an early version of that invention called a negative feedback amplifier. In the early days of long-distance calling, only a few voices could be carried on one pair of wires. As long-distance calling grew, high-capacity systems were needed to carry many telephone calls simultaneously. But signals used in high-capacity systems need to be amplified more frequently, and the available amplifiers distorted the signals. In 1921, Harold Black began working on an efficient, distortion-free amplifier that would permit long-distance transmission of large numbers of telephone calls at low cost.
I tried again and again to build practical or viable amplifiers that would accomplish what I was trying to do. And each and every one was a total failure. Some, even when I made a sketch, I could see that I was getting nowhere. And when I say nowhere, I mean nowhere. And then came the fateful morning in August of 1927. I boarded the ferry and went to work just like any other day. I was looking at the Statue of Liberty, and all of a sudden, the idea came to me in a flash. I thought of how to make the negative feedback amplifier. Then I bought a New York Times. I had nothing to write on, so I bought it. And I opened the pages, and it was a mere accident that that particular day I had the name of a newspaper and the date, and then the entire page was almost a very clean page. And I by no means filled it. I spent a little time making the diagram. I called it a canonical diagram because it is universal and applies to anything: electrical, mechanical, chemical, hydrodynamical, any wave system that you can think of. When I got to the laboratories, and I ran to get there in a hurry, I had that immediately witnessed and understood by E.C. Blessing, one of my associates. Then I showed a copy of my diagram to S.T. Myers and asked him to assemble the parts so that we could proceed with the making of a working model. As the morning wore on, he was doing well, had many of them mounted, but every 15 minutes I kept walking into the laboratory and saying, "Steve, how are you doing?" And he said, "Harold, I am doing fine, but if you would just leave me alone, go back in your office, relax, put your feet on the desk, and maybe there will be other problems of the negative feedback amplifier that need to be attended to." Well, that proved to be a better piece of advice than Steve intended, I am sure, because by the end of the year, we had a broadband negative feedback amplifier working, which, curiously enough, had as much as 50 decibels of negative feedback, more than enough to accomplish the job that I had started in December of 1921.
The negative feedback amplifier works this way. At the input is the low-level signal you want to amplify. At the output is the amplified signal, magnified in the way you want. But the amplifier introduces distortion, which is also magnified. By connecting a small portion of the output back to the input, the distortion is canceled, and the signal becomes clear. Since the invention of negative feedback, Harold Black has received more than a dozen major awards and has been named a Fellow of 10 professional societies. He still recalls the day when it all began with a flash of recognition more than 50 years ago.
The flash of recognition is something that I was unable to understand at the time, and in the 50 years that have gone by, and I have thought of it again and again. I have no explanation whatsoever.